Here's a problem. We have a function f of x, which is x to the fourth minus 6x squared minus 8x plus 5. We want to know where it's increasing, where it's decreasing, where it's concave up, and where it's concave down. So we need to analyze f prime and f double prime. So let's start with f prime. F prime of x equals 4x cubed minus 12x minus 8. And we need to factor it because if we have it in factored form, we can tell where it's positive and where it's negative. So the common factor here is 4. We get x cubed minus 3x minus 2. So now factor this cubic polynomial. In general, they're difficult to factor, but in this one, we notice that negative 1 will make this 0 if x is negative 1. So then you get a 0 here. So x plus 1 is a factor by the factor theorem. And now we need to figure out a quadratic polynomial that if you multiply it by x plus 1, you will get x cubed minus 3x minus 2. And this you can do by long division, or you can do it this way. So in order to get x cubed, I need an x squared here. So x squared times x is x cubed. And then x squared times 1 is x squared. But there is no x squared here. So to get rid of it, I subtract an x here because minus x times x is minus x squared. And then minus x times 1 is minus x. So the x squares here cancel. Now I have minus x, but I need minus 3x. So to create that, if I put a minus 2 here, then minus 2 times x is minus 2x. And that gives me the minus 3 that I need. And then minus 2 times 1 is minus 2, and that checks 2. So this is the factored form of that. Now this quadratic happened to be factorable too, so I can continue by factoring this quadratic. X plus 1 and x minus 2 are the factors. You can check by FOIL. So now I have f prime of x, and that's equal to 4 times x plus 1 squared times x minus 2. And that gives me the critical points. Which are -1 and 2. So these are the two places where I need to check the derivative, whether it changes sign or not. But let's do the second derivative and then we make a table. So the second derivative is, I'm going to use the original f prime. It's easier to differentiate that, so I don't need to expand this or use product rule. So derivative of f prime of x is 12 x squared minus 12. That this 2 is factorable. 12 times x squared minus 1, and that's 12 times x minus 1 times x plus 1. So these are more points of interest. It gives me more points of interest. Those are where the f double prime change sign, and they are plus or minus 1. So now we make a table. So we have these values for the table, and that's this over here. So we need to locate these on the number line. There is a -1. They both share -1, f prime and f double prime, and +1 and 2. So the -1 is here, right? And this is +1, and this is 2. So we look at the factored forms of f prime and f double prime, and then we can figure the signs, whether they are positive or negative. For f prime, let's do f prime first. For f prime, when x is less than -1, the square one here is always positive. A number less than -1 minus 2 is negative, so that makes this negative here. At -1, f prime doesn't change sign because it's this factor x plus 1 is an even factor, so it doesn't change sign. And you can also check a number between -1 and 1, like 0, for example. Put in 0, you get a negative quantity, so that's negative. Similarly, here, still negative, but at 2, it changes sign. When x is greater than 2, this whole thing would be positive. So now let's do the second derivative. And the second derivative has these factors. It changes sign at 1 and at -1. For x less than -1, this is negative and that's negative. Negative times negative is positive. At -1, it changes sign, so this has to be negative because this is a factor x plus 1. On one side is positive, on the other side of -1 is negative. So that's why it changes sign. And you can also try some numbers. At 1, this 2 changes sign. So between 1 and 2, it's supposed to be positive. And you can also notice if x is bigger than 1, the first factor is positive. And the second one is positive. Positive times positive. And for x greater than 2, it's definitely positive. So now we can see whether f is increasing, decreasing, or concave up or concave down. So here, for less than -1, f prime is negative, so f is decreasing. F double prime is positive, that means its concavity is upward. Here f prime is negative, so it's decreasing. F double prime is negative, so concavity is downward. F prime negative, decreasing. F double prime positive, concavity upward. F prime positive means increasing. F double prime positive, concavity upward. So now we can finish the problem. F is increasing on 2 to infinity. It's decreasing on negative infinity to 2. So this is where x is 2. F is concave up on, this is up here, from negative infinity to negative 1, and it's also up here from 1 all the way to infinity. These are all positive there. So union 1 to infinity. F is concave down here. This is the only interval, negative 1 to 1. Now F has a local minimum at x equal to 2. By the way, this is the first derivative test. 2 is F prime is negative on the left, positive on the right. So at x equal to 2, it has a local minimum. F has an inflection point. What is an inflection point? Inflection point is where the concavity changes. So the same role a local minimum or maximum plays for F prime, inflection point plays for F double prime. That's where the F double prime changes sign. So the concavity changes. And there is one here. This is concavity upward, downward. So this is an inflection point. And here concavity is downward here, over there is upward. This is another inflection point. So they are at x equals plus or minus 2. So this is a minus 1. This is a plus 1. So plus or minus 2. And that concludes the video.